This is integers and absolute value. Integers are any numbers that are part of the whole number set, like 0, 1, 2, and 3, and so on. And they're opposites. So 0 is its own opposite, 1's opposite is -1, 2's opposite is -2, 3's opposite is -3, and so on. Those numbers are our integers. Absolute value is any number's distance from 0. If we look on a number line, we can compare any number to 0. So here's 0, here's -5 on the number line. It is 5 units from 0. If I were to walk there, I'd walk 1, 2, 3, 4, 5 units. So -5's absolute value is 5. It's 5 units from 0. Since absolute value is a distance, it's always measured in a positive integer. All absolute values are positive because they represent distances. We don't have negative distances. So just to review, the absolute value of an integer is the distance between the number and 0 on the number line. And the absolute value of a number, let's say that number is A, is written between two very long bars with our A in the middle. So basically, when we see this notation, they're asking us for the absolute value of this A value here. So let's look on the number line and compare two integers. Let's compare 4 and -4. Both are 4 units away from 0. +4 is 4 units to the right. -4 is 4 units to the left. So if I'm being asked the absolute value of -4, the distance this number is from 0, it's 4 units. 4 is also 4 units from 0. So they both have an absolute value of 4. Notice absolute value, always positive. And opposites share the same absolute value. They're both the same distance from 0 in opposite directions. All right, let's take a look at an example. So we're being asked to find the absolute value of 2. So here's 2 on my number line. To get from 0 to 2, I have to go 2 units. 2 units to the right. The direction doesn't matter as long as I know it's 2 units. So the absolute value of 2 is 2. It's 2 units from 0. How about the absolute value of -3? So here's -3 on our number line. From 0, I have to go 1, 2, 3 units to the left. The direction doesn't matter, just the amount of units, which is 3. So the absolute value of -3 is 3. It's 3 units from 0. Let's compare 1 and the absolute value of -4. So since this one is an absolute value, I'm going to find -4 on my number line. From 0, it's 1, 2, 3, 4 units away. So the absolute value of -4 is actually worth 4. And if I compare that to 1, 4 is larger. So the absolute value of -4 is actually larger than 1. Let's look at a real-life application. The freezing point is the temperature at which any liquid becomes a solid. So butter's freezing point is 35, airplane fuel, -53, honey, -3, mercury, -39, and candle wax, 55. So they want to know which substance has the lowest freezing point. It freezes at the lowest temperature. And the one with the lowest out of all these is airplane fuel, which sounds good to me because if I am flying in an airplane, the last thing I want is for the fuel to freeze. Second question, is the freezing point of mercury or butter closer to the freezing point of water, which is 0 degrees Celsius? So if water is 0, butter is 35 degrees away from that. It's 35 degrees above 0. Mercury is 39 degrees away. It's 39 degrees below 0. So if this one's 39 units from 0 and this one's 35 units from 0, the one closer to the freezing point of water is butter. Finally, is the freezing point of airplane fuel or candle wax closer to the freezing point of water? And explain your reasoning. All right, so airplane fuel freezes at negative 53, so it's 53 degrees Celsius from 0. And candle wax freezes at 55 degrees Celsius. So they want to know which is closer to the freezing point of water again. It's going to be the airplane fuel, because that one's only 53 degrees away from 0. And candle wax is 55 units away from 0. So airplane fuel, because 53 units is less than 55 units, which is what candle wax is from 0.